You're moving right now, 230 kilometers per second, around something you've never seen, something 26,000 light years away that's been pulling you in a perfect circle since before you were born. Your parents orbited it, every ancestor stretching back through time, every human who ever lived, every star you've ever seen burning in the night sky, all of it. 200 billion stars, gas clouds, planets, every piece of the Milky Way locked in vast patient orbits around the same invisible point. And at that point sits something that shouldn't exist by any reasonable standard, a supermassive black hole. 4 million times the mass of the Sun, invisible, silent, absolute. For most of human history, we didn't even know it was there. Tonight, we're tracing the story of Sagittarius A star, the invisible tyrant at the center of everything we know, the dark heart ruling the Milky Way. Let's begin. For thousands of years, humans looked up and saw the Milky Way as a soft band of light smeared across the sky. Faint, beautiful, meaningless, just light. By the early 1900s, we finally understood what we were looking at. A galaxy, spiral, vast. With us stranded off to one side, about 2/3 of the way out from whatever the centre was. We knew there had to be a centre, some dense region where starlight pooled thicker, but we assumed it was just more stars, closer together, brighter, nothing unusual, nothing dangerous. The problem was we couldn't see it. Between us and the galactic centre, enormous clouds of gas and dust block all optical light completely. When you point a normal telescope towards Sagittarius, you see nothing. Darkness. For centuries, the centre of our own galaxy was hidden behind a wall we couldn't breach. Then, in the 1970s, radio telescopes began scanning that darkness. Radio waves pass through dust like it isn't even there, and they found something wrong. A powerful, compact radio source. Bright, concentrated, unmoving. Far too bright to be starlight, far too small to be a star cluster, too concentrated to be gas. They named it Sagittarius A star after the constellation where it appeared in our sky. Something massive was there, something we couldn't see, pulling everything toward it with gravity we could measure but not understand. But here's the problem with black holes. You can't see them. You can only see what they do to everything else. In the 1990s, 2 teams of astronomers began one of the most patient, brutal experiments in the history of science. Keck Observatory in Hawaii, the Very Large Telescope in Chile. Both aimed at the same patch of absolute darkness near the galactic center. Using infrared cameras that could see in wavelengths our eyes can't detect, they began tracking individual stars near Sagittarius A star. Not hundreds of stars, a few dozen. Year after year, image after image, frame by frame, watching them move, and the stars moved fast, not the slow, lazy drift you'd expect from objects orbiting something 26,000 light years away. These stars were whipping around something invisible like planets circling a sun, but far more extreme. Tight orbits, elliptical, violent. One star became the key to everything, a blue-white star, unremarkable in every way except for where it was and how it moved. The teams called it S2, and S2's orbit would prove what we'd been orbiting our entire lives. S2 orbits Sagittarius A star every 16 years. That's absurdly fast for something orbiting the centre of a galaxy. Our Sun takes 230 million years to complete one orbit. S2 does it in 16. At periapsis, the point where S2 comes closest to the black hole, it gets within 17 light hours of Sagittarius A star. For context, Neptune sits about 4 light hours from the Sun. S2 gets 4 times closer to a supermassive black hole than Neptune gets to our Sun. And at that distance, S2 accelerates to about 2 to 3% the speed of light, around 7,000 to 8,000 kilometers per second. Fast enough to cross the distance from Earth to the Moon in under a minute. Scientists followed S2 for decades. tracking its motion year after year with obsessive precision. They watched it sweep past the black hole in 2002, then again in 2018. One full 16-year orbit from close pass to close pass, and the next orbit is already underway. Frame by frame, year by year, they watched it accelerate as it approached periapsis. They watched it decelerate as it moved away. The path was perfect, Keplerian. Exactly what you'd expect from an object orbiting a massive point source. Then they did the math. To make a star move that fast in an orbit that tight, there has to be something unimaginably massive at the centre, concentrated in a space smaller than Mercury's orbit around the Sun. The numbers were precise, roughly 4 million solar masses. No star cluster could be that dense without collapsing instantly. No gas cloud could stay together under that kind of gravity. No normal object could hide that much mass in that little space. Only one thing fit: the evidence, a supermassive black hole. By 2002, the case was closed. Sagittarius A star wasn't just a radio source, it was a black hole. Our black hole. For decades after that, we knew it was there. We could measure its mass, track stars orbiting it, map its gravity with mathematical precision, but we'd never seen it. We couldn't. Black holes don't emit light, they trap it. In 2019, the Event Horizon Telescope, a planet-sized network of radio dishes working together as one instrument, revealed the first ever image of a black hole. M87 star at the centre of a galaxy 55 million light-years away. A glowing ring of superheated gas, a shadow in the centre. Proof that event horizons are real. And then, in May 2022, the EHT released a second image, this time closer to home. Sagittarius A star. It took longer than M87 star because Sagittarius A star is far more difficult to photograph. M87 star is massive and stable. It changes slowly over days or weeks. You can watch it, Sagittarius. A star is smaller and flickers constantly. Gas swirls around it on timescales of minutes to hours. Brightness shifts unpredictably. It's like trying to photograph a child who won't sit still, while the child is also 26,000 light-years away, and you're using telescopes scattered across an entire planet. But the teams synchronized data from telescopes in Chile, Hawaii, Arizona, Mexico, Spain, and the South Pole. Multiple observatories working as one, combining signals, compensating for Earth's rotation, adjusting for atmospheric distortion, building an image pixel by pixel over years of work. And then they had it. A bright ring of hot gas bent into a circle by gravity, circling the event horizon. And in the centre, a shadow. A dark silhouette where light is captured and never escapes. 52 microarc seconds across, like seeing a donut on the surface of the moon from Earth, or reading a newspaper in New York from Los Angeles. For the first time in history, we saw the face of the thing we've been orbiting our entire lives. And here's the strange part. Sagittarius A star is not a quasar. It's not blazing. It's not devouring stars every night in a feeding frenzy. Most of the time, it's quiet, starved, a giant sitting at the table with its mouth closed, which means we're looking at something even stranger than a monster actively feeding. We're looking at a supermassive black hole at rest, and seeing it forced us to ask a question we'd been avoiding. What are we actually looking at? What does 4 million solar masses really mean? 4 million solar masses? That's 4 million stars like our Sun, compressed into a singularity. Let's put that in context you can't ignore. If you could somehow compress our Sun, this 1.4 million kilometre wide ball of fusion that gives life to everything on Earth, into a black hole, it would have an event horizon about 6 kilometres across. A tiny sphere you could drive around in 10 minutes. Now imagine doing that 4 million times and crushing all of it into a single point in space. That's Sagittarius A star. The event horizon of Sagittarius A star is about 24 million kilometres across, roughly 17 suns laid side by side. Light, moving at 300,000 kilometres per second, crosses that diameter in about 80 seconds. A minute and 20, that's the boundary, the point of no return. And it's worth saying this out loud because it matters. The event horizon isn't a surface, it's not a shell you can touch. It's a line in space where escape stops being a direction you can move in. Inside it, every direction points inward. Time and space trade places, our everyday ideas about up, down, forward, back, they all break. Not because the black hole is made of darkness or magic, but because gravity is so extreme that even light travelling at maximum speed can't climb back out. And deeper still, beneath the horizon, our equations predict a singularity, a place where the math stops making sense and physics runs out of language to describe what happens. Now, if you put Sagittarius A star where the Sun is, the event horizon would still fit comfortably inside Mercury's orbit, but the mass would be 4 million suns. Earth, at our current distance of 1 AU, wouldn't be able to orbit the way it does now. To stay in a stable orbit at Earth's distance from a black hole that massive, you'd need to travel at about 1/5 the speed of light, and your year would last just over 4 hours. So the horizon is small compared to the solar system, but the gravity is not. The gravity is overwhelming. Now consider the mass itself. The Sun weighs about 333,000 Earths. It's so massive that its gravity holds 8 planets in orbit across billions of kilometers. Sagittarius A star is 4 million times more massive than that. That's 1.3 trillion Earths, 1,300 billion Earths. If you somehow lined up planet-sized objects, each one as massive as Earth, you'd need 1.3 trillion of them to equal Sagittarius A star's mass. Lined up edge to edge, that chain of Earths would stretch to the nearest star and back about 200 times. Let's compare it to other black holes so you understand where Sagittarius A star sits in the hierarchy. Sagittarius A star, 4 million solar masses. M87 star, the black hole we photographed in 2019, 6.5 billion solar masses. TON 618, one of the largest black holes ever discovered, 66 billion solar masses. TON 618 is 16,000 times more massive than Sagittarius A star. By comparison, Sagittarius A star is tiny. But tiny is a dangerously relative term when you're talking about something with the mass of 1.3 trillion Earths. And Sagittarius A star is 26,000 light-years away, the closest supermassive black hole to Earth. When we look at Sagittarius A star, we're not seeing it as it is now, we're seeing it as it was 26,000 years ago. Humans were living through the last ice age, small bands huddled around fires, stone tools, animal skins, the first. Cities were still 10,000 years in the future. Writing didn't exist. Agriculture hadn't begun. Civilization was nothing but a distant possibility. And light left Sagittarius A star and began its journey toward Earth. Through dust, through spiral arms, through the quiet lanes between stars, until it finally reached our telescopes in 2022. Sagittarius A star is ancient. It likely formed in the early universe billions of years ago when galaxies were young and still colliding and merging in violent chaos, when the first stars were just beginning to illuminate the cosmos. Sagittarius A star was already there when our solar system formed 4.6 billion years ago. Already massive, already ancient. It was there when life first appeared on Earth, when the dinosaurs ruled and died, when the first humans looked up at the night sky and tried to understand what they were seeing. It will still be there long after the sun dies, long after Earth is gone, long after every star we can see has burned out or drifted away into the expanding void. And it's been doing the same thing the entire time, pulling, holding, anchoring everything. Right now, in this present moment, Sagittarius A star is doing something. Pulling gas inward, maybe flaring as a cloud drifts too close, maybe quiet. Stars are orbiting it. S2 is somewhere in its 16-year path. Other stars are accelerating toward periapsis or drifting away. The event horizon is there. The ring of light is glowing. Something is happening right now. but we can't see it. The light that would show a Sagittarius A star as it is right now, in this exact moment, won't reach Earth for 26,000 years. Think about that for a second. 26,000 years from now. Modern humans appeared roughly 300,000 years ago. 26,000 years is nearly 1/10 of the entire span of human existence. In 26,000 years, human civilization might be unrecognizable. We might have spread across the galaxy, or destroyed ourselves, or evolved into something we wouldn't recognize as human. Earth's climate will have shifted. Continents will have drifted. Species will have gone extinct. New species will have appeared. The stars in the night sky will have moved to completely different positions. And only then, 26,000 years from now, will the light from today's Sagittarius A star finally arrive. Only then will observers, if there are any left, see what Sagittarius A star looked like in the year 2026. We're always watching the past, never the present. The black hole we photographed in 2022, that was Sagittarius A star as it existed 26,000 years ago. SDU's orbit that we've been tracking since the 1990s. We're watching events that happened 26,000 years before we saw them. Everything we know about Sagittarius A star, every measurement, every observation, every image, is ancient history by the time it reaches us. And there's no way around it. Light has a speed limit. Information has a speed limit. We're separated from Sagittarius A star not just by distance, but by time itself, a 26,000-year gulf we can never cross. What is Sagittarius A star like right now? We can't know, not for 26,000 years. All we have is the past, always the past. But the past is enough to tell us what Sagittarius A star does. Sagittarius A star doesn't hold the entire Milky Way together by itself. The galaxy is bound by all of its mass. Stars, gas, dark matter, everything added together creates the gravitational web that holds the galaxy in one piece. But Sagittarius A star rules the inner heart of it. Near the core, its gravity dominates absolutely. It sets the rhythm of the closest stars. It anchors the very centre we measure everything from. And in that sense, quietly, relentlessly, it is the dark landmark at the centre of home. We orbit at 230 kilometers per second, fast enough to circle Earth's equator in about 3 minutes, but the galactic centre is so incomprehensibly far away that one complete orbit takes about 230 million years. Think about that. The last time, our solar system was in this position in its orbit around Sagittarius A star. Dinosaurs hadn't appeared yet. Pangaea was still intact. The next time we come back around to this exact spot 230 million years from now, Earth might be unrecognizable, or gone entirely. Stars closer to Sagittarius A star orbit faster. S2 completes an orbit in 16 years. S62, another tracked star, completes its orbit in just 9.9 years, screaming around the black hole at nearly 10% the speed of light at periapsis. Farther out, stars take thousands of years per orbit, and at the edges of the galaxy, 70,000 or 80,000 light-years from the centre, stars crawl through their orbits over hundreds of millions of years. Some stars have been circling Sagittarius A star for billions of years. They'll keep circling for billions more. Generations of stars born and dying, all held in orbit by the same invisible anchor. Sagittarius A star doesn't care. It doesn't hurry, it doesn't rest, it's patient, invisible, silent, absolute. Every star near the core bends to it. Every orbit, every trajectory, every motion shaped by its gravity. You can't negotiate with it. You can't escape it. We're bound to it. The quiet tyrant at the centre of everything. Right now, somewhere near the constellation Sagittarius, there's a black hole. You can't see it with your eyes. You can't point to it in the sky and say, there it is. But it's there, and you've been circling it your entire life. So have your parents. So has every generation before you. So has every star you've ever seen. All of it held by something we couldn't even photograph until 2022. Something we still can't see as it is, only as it was 26,000 years ago. the dark heart of the Milky Way. Not the most massive black hole in the universe, not the farthest, not the brightest, but ours, the centre of home, patient, quiet, inescapable. You're orbiting it right now. You were orbiting it when you were born. You'll be orbiting it when you're gone, always, turning, never arriving, always seeing it late, never seeing it now. The invisible thing at the centre of everything. The thing you can't escape. The thing you've always been bound to without knowing it. Sagittarius A star, the dark heart of the Milky Way.